Looking at solving linear inequalities is very similar to looking at solving linear equations. In fact, we're going to use exact same steps with one small change in the final step. And that final steps change is going to be that when we get rid of multiply or divide by multiplying or dividing both sides by a number, if both sides are multiplied or divided by a negative number, we need to turn the inequality symbol around. So I'm going to go ahead and jump right into these examples because we've all seen these before. There are 3 examples total, and in my examples I'm going to solve the inequality and then I'm going to graph my solution. So going ahead and jumping into number 1, my first step, just like with solving, is to distribute. Since I do have parentheses, I'm going to go ahead and take that step. And distributing the 2 in gives me 2x minus 8 plus 6 is less than negative 8. Next thing I'm going to do is combine like terms on each side. So now instead of looking at each side of the equation or the equal sign, I'm going to look at each sides of the inequality. So I see on my left side I have a negative 8 and a plus 6 I can put together since neither of them have a variable. So I'm not doing anything with the 2x, so it drops down. Negative 8 and positive 6 is negative 2, or subtract 2. My inequality symbol drops down, so I still have that less than symbol, and so does the minus 8. Next thing I'm going to do is make sure I have the variable on only one side, and I already have the variable on only one side, so I can skip step 3. Then I'm going to look exclusively at my side with the variable and try to get rid of any adding or subtracting, so I'm going to get rid of a subtract 2 by adding 2 to each side. Again, everything drops down, so the 2x, which I haven't done anything with, my inequality symbol, negative 8 and positive 2 is negative 6. And my next step, I'm going to go ahead and divide both sides by 2. I remember that on my next step, that's when there's a possibility for things to change. But I notice the only thing I have to be aware of is if I multiply or divide both sides by a negative. Well, I divided both sides by a positive 2. So nothing changes, my inequality does not change, and I'm left with x is less than negative 3. So for my last step, if I were to graph my solution here, just like before, I'm going to go ahead and label just a couple points here on my graph. I'm going to put an open circle at 3. And because this is red, x is less than negative 3, I'm going to shade the left side of negative 3. And that will be my solution and the graph to my solution. I'm going to go ahead and look at example 2 next. Feel free at any time to pause this video and try the example on your own first. Doing example 2, my first step is to distribute, but because I do not have any parentheses, I can skip that step. Then I'm going to look at both sides of my inequality symbol, and I see I have like terms. I have a 3x and a subtract 6x. So 3x subtract 6x, or 3x and negative 6x, is a negative 3x. My minus 5 drops down. My inequality symbol drops down and doesn't change. And the 13 drops down. Next thing is I want to make sure the variable is on one side. I've already got that, so I can skip step 3. Step 4, looking at the side with the variable, I'm going to go ahead and get rid of a subtract 5 by adding 5 to both sides, leaving me with a negative 3x on the left is greater than or equal to 18. And for my last step, I'll get rid of that multiplication, so I have negative 3x, which is the same thing as negative 3 times x. So to get rid of the times negative 3, I'm going to go ahead and divide both sides by negative 3. But I'm aware right now that I'm dividing by a negative, so I have to remember that when I rewrite my next step, or what my result is from this step, I have to make sure that because I divided both sides by a negative, to flip my inequality around, giving me x is less than or equal to negative 6. I'm going to go ahead and I'm going to graph this inequality. I'm going to go ahead and put a couple numbers on my number line. And I'm going to use a closed circle this time since it's or equal to. And I'm told that x is less than or equal to negative 6, so I'm going to again shade everything to the left of negative 6. And again, making note that the reason I moved or changed my inequality here was because I divided by a negative. The reason that I left it alone here is because I divided by a positive. So I only change it if I divide both sides or multiply both sides by a negative. Looking at my third and final example, I can't see my steps anymore, but hopefully you have them on either a notes template or written in your notes. First thing I'm going to do is check to see, can I distribute? And I see that I can distribute a minus sign in on the left, and I can distribute a 2 in on the right. So my 4 drops down, minus 2x, minus 3, minus 4x after the minus sign drops in, or excuse me, distributes in, less than 2x, minus 20. Now I'm going to look at each side. I'm going to ask myself, do I have like terms? And I notice that I have a minus 2x and a minus 4 I can put together. I also have a 4 and a minus 3. Well, 4 minus 3 is 1. Minus 2x minus 4x is minus 6x. It's less than 2x minus 20. Now I ask myself, do I have the variable on only one side? And since my response is no, I'm going to choose to either get rid of that minus 6, get rid of the minus 6x, or get rid of the 2x. I, for the most part, like to typically get rid of the smaller one, so I'm going to go ahead and get rid of that minus 6 by adding a 6x, but if I add a 6x to the left, I also have to do it to the right. Leaving me with 1 is less than 8x minus 20, so I've successfully gotten the variable on only one side. Looking at that side, I want to get rid of add or subtract, so I'm going to add 20 to get rid of the minus 20. And I now have 21 is less than 8x. And finally getting rid of multiply or divide, and it is 8 times x, so getting rid of multiply by dividing by 8. 8 is a positive number, so I'm not going to flip my inequality. I get 21 over 8 is less than x. I am perfectly happy with a fraction solution. However, when I go to graph this, it will be more helpful when I'm constructing my number line to know where to put that between which two numbers. So if I were to change that to a mixed number, it would change to be 8 goes into 21 twice with 5 left over. So 2 and 5/8. So graphing that, I know 2 and 5/8 is going to fall in between 2 and 3. And if here's my halfway point, it's going to be just above my halfway point because 2 and 4/8 is what would reduce to 2 1/2. So I'm going to put an open circle there. Remember, I always read the variable first, so I read this as x is greater than 2 and 5/8. So where am I greater than 2 and 5/8? Well, I'm greater to the right. So I'm going to go ahead and shade this side here. And now once again, I have my solution in my graph. So as you can see, very similar to things we have already done, just making sure to remember, like I did here in the example 2, that if I multiply or divide both sides by a negative to turn my inequality around. Make sure to bring any questions with you into class.